In many cities all over the world, clean water is both scarce and expensive to produce. Water utilities are facing enormous challenges when treating and distributing water in sufficient quality and quantity for their ever-increasing urban populations. At the same time, 45 million cubic meters of clean drinking water are lost in the world's water systems every day. This quantity could serve the needs of nearly 200 million people and has an estimated annual value of over 18 billion US dollars. In megacities like Manila, Sao Paulo and Mexico City, more than 50% of the water supply is lost each year. Around the world, policymakers and water experts are struggling to cope with this problem.
We are currently, as a utility, losing about 52% of the water that we produce. Now, the challenge that we have is to see how we can drop the water loss reduction rate from 52% to an acceptable number, say about 25%.
In our country, the water loss is very high in rural area due to old network and low quality of house connection.
The water loss exceeds more than is going from 30–35% up to 70%.
Water utilities play a crucial role in addressing water loss. But in rapidly growing cities, especially those in emerging economies, water utilities often lack the appropriate management capacities and institutional frameworks to effectively address these challenges in the long term. Through a series of conferences and workshops, UNWDPC is working to identify existing gaps in capacities and put forward solutions to deal with this situation. In association with a large number of water sector professionals, UNWDPC provides services to stakeholders and guidance on how to satisfy the huge educational, technical and investment needs to raise professional capacities in the water sector.
Water loss is a global problem with a technical, managerial and administrative dimension. Water loss is impacting on all countries, rich or poor, with high engineering capacities or with low capacities. Water loss is not yet receiving the attention it should receive. Our program, UN Water Decade Program on Capacity Development, which is called UNWDPC, in cooperation with UN Water members and partners, have therefore organized a series of workshops in Germany, in Bulgaria, Mexico, and in Morocco since 2008. About 510 participants from different sectors related to this issue from 37 countries participated in these training programs.
The Bulgarian capital, Sofia, is an example of a city with an old water distribution network. The pipe system was built in the 1950s and 60s, and over time, problems with corrosion have meant that more maintenance and repairs are needed.
The problem we have with the materials in the system is that we have a high proportion of asbestos cement pipes, which do cause a big problem. Many leaks, many bursts. We have an average of about 1,000 repairs per month on our system here.
In Sofia, a conference supported by UN Water Decade Program on Capacity Development, UN Habitat and the International Water Association, together with the national water associations from Bulgaria and Germany, brought together practitioners from 12 countries.
The setting up of a regional workshop on improving urban water efficiency is having the effect of creating a living regional and inter-regional network of practitioners and organizations that are able to exchange and disseminate their knowledge and experiences in reducing water loss across the world.
Engineers, technicians and policymakers exchanged insights on successful cases of water loss reduction and improved leakage control. They agreed that while solutions are available, the main challenge is how to more effectively share the best available knowledge between water managers in all countries. There are many technical solutions for pipe maintenance and leak detection available today. This knowledge needs to be shared more effectively. In Sofia, technicians from the water utility work with acoustic loggers to document the sound water leakages produce in the metallic pipe systems. When the pipes leak, there is vibration that can be measured from a distance. In another part of the world, in Morocco, a similar technical team from the local water utility also works with acoustic loggers and an additional correlator. Using this method, the technicians place sensors on the pipes at 2 points. Similar to the traditional acoustic loggers, the correlator relies on the sound generated by the leaks. The sound emitted by the leak reaches 2 different measure points at different times. Using this data, the technicians can accurately calculate the location of the leak. Additionally, the technicians check the ground with an aquaphone. The signal indicates that the leak is at a pipe intersection below the pavement. In the third regional focus of UNWDPC's workshops, set in Guanajuato, Mexico, the local water utility, like many other utilities in mountainous areas, has to pay careful attention to water pressure in the pipes. Pedro de la Cruz Mares, one of the senior engineers, works on a computerized terrain model, digitally representing the ground surface. Using an advanced global positioning system, he accurately measures the location of the water pipes.
Nos permite obtener la diferencia de alturas en la zona de trabajo. Como podemos observar, la ciudad de Guanajuato tiene una topografía muy accidentada, lo que dificulta los trabajos de manipulación del agua potable. Al tener esta información, vamos a poder saber qué distancia existe entre cada uno de los elementos, qué desnivel existe entre cada uno de estos puntos. Esta información se caracteriza por estar georreferenciada en un sistema único.
Another team monitors the pressure in the pipes. Effective pressure management can significantly reduce the frequency of new leaks and bursts, reducing repair costs and saving water. With digital pressure and velocity loggers, the technicians measure the flow in the pipes over a longer period of time. With accurate information about the diameter and material of the pipe, the team can calculate the volume of water running through the pipe.
Al tener la instrumentación de presión y gasto de salida, podemos conocer el consumo y el padrón y las curvas de demanda de cada uno. Toda esta información que la tenemos a través de todos los equipos nos ayudarán a alimentar un modelo matemático para dar soluciones para control de presiones y sectorización.
The water utility in Guanajuato serves as an excellent example of good planning and management, with effective investments in ongoing operations, electromechanical and technical systems. On-site technical data is fed into a central database. Technicians enter topographical data and link it with locations of pipes and reservoirs, together with data from the pressure loggers on the pipe systems. A mathematical model is used to assist with the overall monitoring of the water distribution system. To improve their services, the water utility has implemented several changes. For instance, it has introduced an automated billing and collection system. They have also reviewed the performance of the water meters in private houses and in the public system. Training programs have been implemented to substantially improve local water services. From this experience, it has become apparent that water management is not simply a technical issue, but also requires institutional changes in order to better cooperate with various local stakeholders.
Y medidas administrativas que tienen que ver con los procedimientos de reporte, atención a fugas, comunicación y lo que es el control geográfico de la atención a los reportes de fuga, que nos permite, por un lado, ubicar en qué zonas de la ciudad tenemos más fugas, mandar a las cuadrillas ya con una idea de los materiales que van a encontrar y llevar un registro de cómo se va comportando el historial de las fugas.
In addition to technical solutions, new conceptual innovations are constantly being introduced. A good example is a conference organized in Rabat, Morocco, on the specific concept of non-revenue water management, which was held back-to-back to the third regional water loss reduction workshop. Non-revenue water, experts explain, is water that is produced and enters the distribution system, but that is never billed to consumers because it's lost due to leakages or informal connections.
Managing non-revenue water allows the utility to use less natural resources, to gain needed revenue, to reduce costs, and to use the most cost-effective source of supply.
The Rabat conference was organized by Aqua in cooperation with UN water members and partners, including the UN Water Decade Programme on Capacity Development, UN Habitat, and the Moroccan water utility ONEP IEA. It brought together 300 engineers, technicians and experts from the MENA region, North America and Europe. There was general agreement at the conference that more widespread adoption of the non-revenue water concept would involve a change in mindset among utilities and consumers.
There's a need for change in the approach of water losses today. So far, water losses, in the 80s, water losses were dealt from a technical point of view and were mainly the real and physical losses. And nowadays we've switched to the more financial approach to the problem.
Water meters play a central role in improving water efficiency by detecting water loss. In order for utilities to know how much water they produce and sell, they need to meter it accordingly. To get water loss under control and raise additional revenue from the water they produce, utilities need to invest in repair and maintenance of the distribution system. Ultimately, what is required is the development of an array of technical, institutional, economic and managerial capacities.
Water efficiency means that you do as much as possible with every cubic meter of water, and that the effort to produce this cubic meter of water is as low as possible.
A cost-efficient water service is crucial for better financial performance of water utilities. This involves user-based water services with accurate monitoring and effective charging for the water used. Meters boost the transparency and accountability of service providers. At the same time, they improve reliability and trust in private service providers.
In Albania, for the past, the people have the, let's say, the experience, don't pay the bill. And for this reason is push too much the people in the forces to pay the bill. And the people don't pay the bill is a start the new strategy to cut the water and to put the people in the court for the payment of the water. And after that, our collection fee was going to the 95–98%.
The workshops, conferences and meetings organized by UNWDPC to date have highlighted the need for greater efforts to ensure water loss reduction. There is still a great deal of work to be done and greater urgency is required, since it's mostly the poor urban populations who suffer the consequences of inaction.
We have had no resources to institute training for this capacity building for these lower levels of staff. So we would like to train everybody in the company so that everybody appreciates and realizes the importance on non-revenue water reduction.
I think more research should be done, and most promising technology is regulating pressure. That is proven technology to reduce either excessive consumption and water losses. In addition to that, there are also institutional aspects, because at this moment there is not efficient system, institutional system in place that will allow for efficient implementation on the national level or regional level of water losses reduction programs.
Continuous capacity development to reduce water loss is crucial to provide sustainable access to drinking water to urban population all over the world. Considering growing megacities, the reduction of water loss is the most efficient sustainable solution to serve large parts of the world's future population with drinking water. In times of climate change, traditional water harvesting and collection methods like dam construction in catchments next to urban agglomerations will not provide sufficient drinking water to all citizens.
The necessary technologies New ideas, financial and human resources to counter water loss are already available. Now is the time for renewed action in order to make greater reductions in water losses. UN Water, with its members and partners, will continue to build capacities and provide support to these vitally important endeavours.